Without the exact position of the camshaft, how does the ECM know which is the event cylinder for a sequentially injected engine? The camshaft sensor is used to relay the exact position of the camshaft to the ECM for specific cylinder or event information. This includes what stroke the cylinder is on, when to inject the fuel, and when is the optimal time to ignite the air-fuel mixture. Without this detailed information, newer model vehicles wouldn't be able to achieve advantages of lower fuel consumption, emissions, and increased horsepower. The sensor is placed in close proximity to a tone wheel or reluctor, separated by a fixed air gap. Older type sensors are typically analog, producing a sine wave output. This type of sensor has two wires, using a low reference and a signal return. While newer engines now use a digital on-off Hall effect sensor for their increased speed and reliability. This sensor is supplied with a high and low reference, with the sensor returning the signal to the ECM. OEMs may choose to use either a pull-up or pull-down circuit for monitoring the signal output. In this module, we'll be looking at the digital type cam position sensor, voltage low and performance DTC. To test the camshaft position circuit, turn the ignition off and disconnect the sensor that has logged the fault. Set the digital multimeter to volts, then place the red lead on the high reference terminal and the black to the low reference. Turn the ignition back on. The meter should display between 4.8 and 5.2 volts. Since this is a pull-up circuit, now move the red lead to the signal terminal. 5 volts should be displayed. If all these voltages were correct, the only possible fault would be the camshaft position sensor. But if these results were incorrect, here are the steps needed to successfully diagnose a voltage low and performance DTC. A short to ground in a pull-up circuit will result in a voltage low code. Turn the ignition off and disconnect the affected cam position sensor harness connector. Place the red lead on battery positive and the black on the signal terminal. Turn the ignition on and watch the meter. Any voltage displayed will confirm a short to ground in the signal circuit. Turn the ignition off and disconnect the ECM harness connector. Turn the ignition back on and watch the meter. If voltage is still displayed, this confirms the short to ground resides in this section of harness. But if voltage disappears when disconnecting the ECM, the short to ground is within the ECM or a circuit from the ECM. To differentiate, perform a continuity test between the signal circuit in the sensor connector and all other terminals within the ECM connector. If no fault is found, the short to ground must be within the ECM. In some systems, excess circuit resistance will set a low voltage code. Turn the ignition off and disconnect the affected cam position sensor. Place the black meter lead on battery negative and the red on the signal terminal. Turn the ignition on and observe the meter reading. 5 volts should be displayed. If substantially less than this is seen, move the red lead and back probe the signal terminal in the ECM harness connector. If the correct voltage is now observed, the excess resistance is between the two connectors. However, if when testing at the ECM, the voltage was still low, turn the ignition off, disconnect the ECM harness connector. Inspect the control module and harness connector for any signs of water ingress and terminal tension. If no fault is found, the excess resistance is within the module. With the ignition off, disconnect the affected cam position sensor, then switch the ignition on. Place the black meter lead on the low reference terminal of the cam position harness connector and the red to battery positive. Battery voltage should be seen. If not, then there may be excess resistance in the circuit. Move the black lead and back probe the low reference terminal at the ECM harness connector. If the correct voltage is now seen, there may be excess resistance in the wiring harness. But if when testing at the ECM the voltage remains low, turn the ignition off and disconnect the ECM harness connector. Inspect for any signs of water ingress or poor terminal tension. If no faults are found, the excess resistance must be internal to the ECM. A signal erratic or performance code will set when the ECM receives a value that's not consistent with the stored algorithm table or cam position map. It may be necessary to warm the engine, tap on the sensor or module, Wiggle the harness and connectors while performing any of the previously mentioned tests. Scan tool data should be observed or recorded for detailed data analysis to rectify any concerns. Take your time and document all your findings when following these test procedures. This will ensure a successful diagnosis of voltage low and performance-based DTCs. Thanks for watching. See you soon.